Welcome to the third episode of the GRAPHERGIA podcast series, The Human Side of Graphene. I am Spyros Yannopoulos, Professor of Physical Chemistry at the Department of Chemistry of the University of Patras and the Research Director at the Institute of Chemical Engineering Sciences of the Foundation for Research and Technology, Hellas. I also have the privilege of coordinating two EU-funded research projects, GRAPHERGIA, funded under the Graphene Flagship Framework, and INERRANT, developed within the Batteries 2030 Plus ecosystem. Both projects focus on the development of novel materials through green, scalable, and sustainable methodologies, with a broader aim of strengthening the technological resilience of Europe in key fields such as smart textiles and electrochemical energy storage. A common dimension of these projects is the development of next-generation lithium-ion battery technologies for demanding applications, including space technologies and electric mobility. The central question is how can advanced materials and sustainable processing routes enable safer, higher performance, and more reliable energy storage systems? Stay with us during our third podcast episode to discover more. Today, we're pleased to host two researchers who proudly represent women in science and technology. Dorela Hoxha, a materials and process here at Pleione Energy, partner in GRAPHERGIA. Dorela, welcome. Could you start by telling us about your research activities within GRAPHERGIA?
Hello, Spyros. Hello, Katrien. Thank you for having me here today with you. As you said, I am the material and process engineer of Pleione Energy, and my work in general in Pleione mainly focuses on advanced lithium-ion batteries, but more specifically in GRAPHERGIA, we are developing a module using batteries, graphene-based lithium-ion batteries for space applications.
Thank you, Dorela. Katrien Boonen is a PhD student at Yana Evangelisti University in Czech Republic and a partner in INERRANT. Katrien, welcome to the podcast as well. Could you briefly introduce yourself and tell us more about your work in INERRANT?
Thank you, Spyros. Hello, Dorela. I'm Katrien Boonen. I'm a PhD student at UJEP, the Jan Evangelista Purkinje University, and I'm also a researcher at IPG, both in Czechia. My background is in biology and bioscience, and I have been focusing in my work on sustainability evaluations. Within INERRANT, we are in this project developing safe and environmentally friendly lithium-ion batteries. And my work specifically focuses on the life cycle assessment, or LCA. Here we analyze the environmental impact, the social impact, and the cost of the new battery technologies being developed over their entire life cycle. And we compare this with the current lithium-ion batteries on the market.
Thank you, Katrien. So, to begin, let us first discuss why lithium-ion batteries are so important for several applications and what challenges still need to be addressed. So, my first question is, why are lithium-ion batteries so central to today's energy transition?
To halt climate change, we need to shift to an energy mix with low carbon dioxide emissions. And for this, we need renewable energy sources like solar and wind energy. However, their production varies over time depending on the weather conditions. So we need some way to store the energy until it's needed. And batteries can help with this. Also in transport, batteries can help the shift to electric mobility.
So my next question is, what are the main limitations or challenges of current lithium-ion batteries in terms of safety, cost, and sustainability?
So I would like to start with saying that the current lithium-ion batteries are already a very successful technology, but there are still important challenges that remain, and we are here to tackle actually. Projects like GRAPHERGIA are working to address these limitations through advanced materials that we're using and also safer battery designs and more sustainable manufacturing approaches. As we all know, one of the major issues is safety, especially overheating under extreme conditions, and another challenge is sustainability. But I think Katrien could also refer to this in more detail. And over the time, cost and performance has also been very important issues that we are trying to find a way how to overcome.
Yeah, so for sustainability, although batteries can obviously help us to reduce the impact on climate change, it's also important to take into account the other impacts they might cause. So to produce the batteries, we still need raw materials, and mining and processing them can cause social impacts. For example, when mining is done outside of Europe, regulations are not necessarily very strict. And also environmental impacts occur due to the mine that can cause habitat destruction. There can also be some pollution of water and soil and air. Another important factor is the criticality of raw materials. Batteries contain some materials that are very important for the economy, but there might be some supply risk. So that's also an important factor that we need to take into account and try to reduce the dependence on these materials in Europe.
Okay, and then what comes to my mind is how do advances in nanomaterial science impact the development of this type of batteries, and in particular, which key challenges do these advances enable us to solve?
Spyros advances in nanomaterial science has allowed us to engineer battery materials in a scale, nanoscale, that has seen to be to provide properties and performances that are very promising and interesting. Material, for example, such as graphene that we're mainly using in GRAPHERGIA, are very promising because they combine high electrical conductivity, they are lightweight, they have mechanical strength, and are very good at thermal management properties that, as we said also before with Katrien, is one of the problems and the limitations that today's batteries have. These advances usually address several important challenges. They can improve, for once, the energy density and the performance, and also it seems that they can charge the batteries, they can improve the charging of the batteries, and also prolong their lifetime. There have been also cases that the safety of the batteries can also be improved by the use of nanomaterials. In GRAPHERGIA, nanomaterials support the development of more sustainable and efficient battery technologies, and they can provide systems that perform much better than the conventional batteries that we are using today.
Okay, so let us now move from the challenges to the solutions being developed in GRAPHERGIA and INERRANT, and how this could support real-world applications in space and electric mobility. So the question is, which solutions is GRAPHERGIA developing? Could you explain the methodology for lithium-ion batteries in GRAPHERGIA?
Yes, we are mainly focused on the graphene-based lithium-ion batteries in a module system for space applications. So we are not only focusing on the cell on its own, which, if I may say, it's produced in a greener manufacturing method, because we're using a dry electrode system that is developed with the laser-assisted technology. So this improves not only the performance from what we have seen, but also it removes the toxic solvents used in traditional methods of production, and it has also been proven to be cost efficient. But in parallel to the development of these technologies for the battery manufacturing, we are also trying to develop the design of the module as a whole system. So we are taking care of the management system, the connections, and the whole design that would be adapted for space applications, and more specifically for a CubeSat. This combination of materials but also architecture would provide us with the advantage of developing a system that will provide better energy, better performance. And as you understand, if we have a better performance, then we can also use less materials and less cells. That would also reduce the total weight of the module, which is a main factor for the space applications.
Fine. And Katrien, how is INERRANT addressing also similar challenges? What is the main lithium-ion battery technologies and methodology?
So INERRANT focuses mainly on developing safe and environmental friendly lithium-ion batteries. What's interesting about INERRANT is that we're not only looking at battery performance, but at the entire life cycle. So starting from the selection of raw materials, the synthesis processes, the manufacturing, up to safety at the consumer and end-of-life recycling. So some improvement focus on the battery safety as partners are developing safer materials and cell architectures. For example, a separator is being developed that when the temperature of the battery increases too much, it will melt and it will stop reactions. Another example is that shear thickening additives are added to the electrolyte. So when there's an impact on the battery, the liquid electrolyte will transform into a solid-like material and short-circuiting will be prevented. So that are some examples for how the safety is improved. Also, sustainability is addressed in several ways. By developing novel synthesis routes, also by selecting chemicals that have a lower impact for the recycling process. For example, organic solvents are used, and this way waste can be reduced and material recovery can be increased. And in all these improvements, the cost efficiency is also an important factor that's taken into account. So different partners across the battery value chain are working together to ensure that all the processes that are being developed can be scaled up and also after the project. So the long-term goal is to manufacture these batteries at a giga scale in Europe.
Fine. Thank you. So finally, let us briefly focus on sustainability, safety, and environmental impact, which are central aspects also in the development of next generation battery technologies. So I have two questions here. One is, how do we ensure that new batteries are safe for users and workers?
Okay, if I may take this one, ensuring that the new batteries are safe for both users and workers, it requires a combination of a lot of testing, a process control during the manufacturing of the batteries, and compliance with the safety standards usually used for the production of the batteries. And more specifically for the users, I would focus maybe on validating the thermal stability, the short-circuit behavior, life cycle of the cells, and pay extra attention to monitoring the risks like thermal runaway, leakage, and even fire of the batteries. And for the workers, the safety starts even beginning from the handling of the materials. So the fact that, from what I understand, both for GRAPHERGIA and INERRANT, we have built sustainable processes that eliminate toxics and provide more sustainable production methods can actually improve the workers' safety. And for sure, we could apply different protection protocols for the manufacturing of the batteries.
Thank you, Dorela. And last question that most probably Katrien is more suitable to reply is, how do you evaluate the full environmental footprint of these batteries?
Well, to evaluate the full footprint, it's important to take into account the complete life cycle of the batteries. So starting with the mining and processing of the raw materials, continuing through all the manufacturing processes, the use by the consumer, and ending with the recycling process. And what we do in a life cycle assessment is for each of the processes within the life cycle, we make an overview of everything that goes into the process and that comes out of the process. And then we convert all those inputs and outputs to environmental impact categories. So, for example, all greenhouse gases emitted through the life cycle in all the processes are aggregated and they're converted into CO2 equivalents. And this way, we can determine which processes in the life cycle have a higher contribution to climate change, and we can take measures to address and reduce these emissions. And something similar is done for many other impact categories. For example, resource depletion, water depletion, acidification, to have a complete picture of the environmental footprint of the batteries.
Thank you very much both for this very insightful use, and thank you for listening to the third GRAPHERGIA podcast episode. We hope you enjoyed our conversation about how graphene and 2D materials can be used to create sustainable energy solutions and help shape a greener future.
Thank you. Spyros, thank you, everyone.
Thank you. Bye.